Okay, let's do this one. Next page. This one's just like your homework. Actually, this is just like the one we did. Okay, we're gonna skip that one. And let's do a harder one. Let's look at this one. You're like, skip the easy, go to the hard. Okay, page 13, on the very bottom. Can I factor that numerator? Yes. Yes. Very good. Difference of cubes. It's always going to come back up sometime, so make sure you memorize it. You are going to remember that is the SOAP method. Same, opposite, always positive. So if you didn't know you had to factor, then basically everything is gone. After that point, you couldn't find the whole, you couldn't find the asymptote, all that stuff. Make sure you memorize that. Difference of cubes. So this is x minus 1, x squared plus x plus 1. In the denominator is a x minus 1, x plus 1. All right, go ahead and analyze that whole thing, and then we'll graph it together again. Okay, vertical asymptote. So first you cancel whatever you can't cancel. The leftover is the vertical asymptote, so that is -1. Horizontal asymptote, the degree on the top is bigger than the bottom, so none. Wholes is going to be at 1 because that's what cancels. You plug it into the reduced function, you get 3/2. X-intercept, so what makes the numerator 0? Yes, go ahead. X squared plus 1 plus x plus 1? You cannot factor that. It's going to give you imaginary numbers. Yeah. So then that means there is no x-intercept, bless you, because there's nothing that will make it 0 except for imaginary numbers, which is not on our graph, so we don't talk about that as the x-intercept. Y-intercept is what makes is when x is 0, so that is 0, 1. All right, this is going to be a strange graph because there is no horizontal asymptote. When there is no horizontal asymptote, we said there is a slant asymptote. So then what happens is our graph is going to be slanted. But you wouldn't be able to know that, so it's going to look strange to you. Okay, so let's graph everything we know. There is a vertical asymptote at -1. The whole is at 1 3/2. X-intercept, Y-intercept is 0, 1. That's it. That's crazy. We don't really know how this looks like. I'm going to tell you a secret of how to find the slant asymptote, because the slant asymptote is going to tell you how the graph looks like. It's not that hard. Basically, long division. No. Long division. X cubed plus 0x squared plus 0x minus 1. Oh, you didn't think you would see this thing again, huh? Well, there we go. Okay, so you don't have to do this, but then, because at this time you only have 2 points, you're like, oh, how does this look like? If you do graph the slant asymptote, it's a little easier to help you graph, but you don't have to do that. Not this year. Next year, yes. Well, I think I put this in the wrong place. X minus x. Subtract down, that is x minus 1. That's it. So the slant asymptote is the quotient. So then it is y equals x. So y equals x looks like this. So our graph is going to look like because without the slant asymptote, you have no idea this graph is going to go slanted. But, yes, you can find the slant asymptote. Yeah, your question. Y equals x. Y equals x is the slanted line. Y-intercept is 0 and goes up 1 over 1, up 1 over 1. So that is the slant asymptote. Okay, that's a very advanced question. Don't worry about it. Let's do an intermediate one. All right, page 14. This middle one. You're like, this is intermediate? Yes, it is. You just need to factor. Yeah.